Welcome back. So on this slide I'm introducing MCDC, Modified Condition Decision Coverage. MCDC basically asks one question: does each individual condition independently affect the decision? So if we have a decision that depends on several Boolean conditions, here I'm labeling them A through E, MCDC imposes three key rules. 1. Each condition, A through E, must be tested as both true and false at least once. The overall decision must also be true in some tests and false in others. And most importantly, for each condition there has to be a pair of tests where only that one condition changes, all the other conditions stay the same, and the decision flips from true to false or from false to true. That last point is what really distinguishes MCDC from simpler coverage measures. It proves that every condition actually has control over the outcome. None of the logic is dead code that never influences the result. On the right, I relate that back to our metabolic syndrome example. Our conditions A, B, C, D, and E are the 5 risk factors: high waist, high triglycerides, low HDL, high blood pressure, and high fasting glucose. This decision we're testing is metabolic syndrome equals A plus B plus C plus D plus E greater than or equal to 3. In other words, metabolic syndrome is flagged if 3 or more of those factors are present. If we tested every possible outcome of A through E, that would give us what we had before, which is 2 to the power of 5, or 2 being the Boolean, 5 being the amount of conditions we have, which gave us 32 tests. Instead, using MCDC, we can get the same logical assurance with just 6 carefully chosen tests, which you can see in the table at the bottom. The bottom right. For this example, I literally just asked ChatGPT to spit out a set of tests that would satisfy MCDC for my 5 conditions. Behind the scenes, it's using the idea that for n Boolean conditions, the theoretical minimum for MCDC is n plus 1 tests. So n is the conditions. We have 5 conditions, so n equals 5, plus 1. It gives us 6, so we should see 6 tests. So there, with these 5 risk factors, we've carefully chosen a set of 6 tests. Now in this set, for A, if you compare T2 and the line T4, only A changes and MS flips. Now for B, you compare T1 and T2. For C, you compare T6 and T5. For D, you compare T4 and T3. And for E, you compare T6 and T2. I won't be leaving you with that explanation. I will actually demonstrate how A and D are arrived at in the next slide. So basically, each condition is independently shown to control the decision of at least once, and that's why there are 6 test sets satisfies the full MCDC coverage for our metabolic syndrome rule, while avoiding the costs of running all 32 combinations. So let's look at the new slide. Here we have A. So this is condition A, which has been highlighted in this column. Test 2 and test 3 are the relevant ones for test A. So we have one condition that we change, which is category A here in this place here. We have 1 in our original T2, and that has been flipped to 0 for our T4. Now we must show that the decision has changed, that is the MS metabolic syndrome condition has changed from T to F. It has indeed. It could also be from F to T. Either way works. Now the rest of the conditions must remain constant. So we need 1, 0, 0, 1 in our line for T4, and we have 1, 0, 0, 1. So there we have 2 tests that satisfy the A condition being flipped and flipping from true to false. Now let's look at D. From D here in T3, we've flipped it from 1 to 0. And if we look at the test result column for the metabolic syndrome, it's flipped from T to F, so we've obeyed that rule. Now the rest of the columns must remain the same. So we've got 0, 0, 1, 1, 0, 0, 1, 1. So they have obeyed the conditions for the rule. And you'll find if you do this for all the other, for B, C, and E, they will also satisfy those conditions. So MCDC coverage has been satisfied by the AI tests that were given to us. So we have shown that our 6 AI generated tests really do satisfy MCDC for the metabolic syndrome rule. Now, I want to zoom out a little bit and ask two questions. When is MCDC actually used in the real world? And what's the sensible way to use AI here? In safety critical domains like avionics, automotive, medical, financial, standards explicitly call for MCDC because we have to prove that every condition in a decision actually matters, and that's what MCDC gives us. AI can help us get there a lot faster by generating truth tables and candidate MCDC sets, but we still need humans to verify the logic and decide if this level of coverage matches the risk of the system. Thank you for joining me in this tutorial. I will be providing more tutorials on AI testing coverage, AI generated testing coverage, so keep an eye out, there's more to come. Thank you.